Our unfathomable lead is way out of this world, 390 light-years away. Truth be told, for setting 1 light-year is undefined, from 6 trillion miles in mankind's resolved excursion for relaxing the insider mysteries of the universe. We've set out on a mission that goes past time itself, looking for replies to mature old solicitations woven into the outer layer of presence. The James Webb Space Telescope, with its unblinking eye, has actually perceived a short look at a construction beginning before the show of stars. This heavenly thing emanated an impression of being more old than the real universe, bringing up a more noteworthy number of issues than it answers. How should an arrangement exist that begins before our universe? Or is the speculation of how things became to fault? Join us as we set out on an odyssey coordinated by the disclosures of the James Webb Telescope. The mysteries of a 13.8 billion-year-old improvement anticipate the excursion to relax these tremendous secrets, which has scarcely begun. In a far-off corner of the universe, around 200 light-years away, an old star called HD 114283 lives near the Libra heavenly body. This famous traveler moves energetically through space, offering interesting brief investigates its fierce past. Definitively 12 billion years ago, during a time when our Milky Way was still in its beginning phases, it ingested a bantam system that once called it home. However, what genuinely piques our infinite interest in HD 114283 isn't simply its quick cycle, it's its astonishing age. Among the heavenly objects we've seen, it remains one of the most seasoned, acquiring the charming moniker Methuselah star, contrasted with the scriptural figure Methuselah, who legend has it lived for a considerable length of time. Originally assessed to be a stunning 16 billion years old, the most recent evaluations suggest a fairly more youthful season of 14.46 billion years, with an edge for mistake of 0.8 billion years. This disclosure about its age confounded stargazers. After all, the age of the universe, as determined from the cosmic microwave background, floats around 13.8 billion years. This issue brought up colossal questions about the star's age, the universe's age, and even the precision of our dating strategies. We should separate it. Sorting out the time of heavenly items can be a real riddle. Take stars, for example. Like the sun, they're similar to eternal lights, maintaining their brilliance, temperature, and size for billions of years, making them captivating to progress in years. Space experts use changes in brilliance and variety as hints, coordinating these with models for seeing how stars develop over time. One age giveaway is the speed at which a star turns. Like a wheel, stars slow down over time. By contrasting the rotational velocities of stars at various ages, cosmologists have worked out a sharp stunt called gyrochronology. Stars additionally spill their age secrets through attractive flares and emanations of energy on their surfaces. These lively signs give space specialists, aka the space investigators, a way to listen in on heavenly discussions. With cutting-edge strategies like astroseismology, they tune in for vibrations caused by waves traveling through a star's interior. These vibrations can reveal a star's age. For instance, applying this technique to the sun, space experts decided its age to be 4.58 billion years. Now back to Methuselah star. The old transmission around it isn't simply conflicting. Cosmologists characterized it with an advanced age by analyzing its grandiose beginnings. Stars can be characterized into bunches based on how much bling or heavy components like iron they have. Our sun is a metalhead, having a place to population 1. Methuselah star, on the other hand, resembles an old artifact from population 2, with less heavy components. It's the heavenly wink-out that assists cosmologists with playing enormous archaeologists, unwinding the age accounts of these sublime animals. Now, envision a gathering of stars, hypothetical population 3, which stargazers suspect may be the universe's most old jewels. However, they're still hiding behind the scenes and haven't yet showed up in our telescope spotlight. Space specialists suspect these stars may be the legends of creation, containing practically no heavy components. To get a handle on the vast arrangement, we really want to rewind to the universe's initial days, just after the Big Bang. Picture an interminable kitchen filled for the most part with hydrogen and helium, the universe's principal fixings, around 92% hydrogen and 8% helium. In this huge troupe, the first entertainers in front of an audience were the population 3 stars. They were gigantic and hot, consuming their fuel quickly, changing hydrogen and helium into heavier components. When these early cosmic beasts detonated, they spread these heavy components into the vast range. Next were the population 2 stars, forming a late but still significant chapter in mankind's early days. Their unique materials were stacked down with heavy components, especially iron. A large number of them went through their heavenly life cycles, impacting into cosmic explosions and adding more heavy components to the universal mix. Finally, the population 1 stars, including our Sun, arose as vast amateurs, forming from cutting-edge gas mists blending in with remainders from the prior population 2 stars. Now, the central question: does the tremendous story toss an endless bend at the hypothesis of the old Big Bang? It's a head-scratcher, yet here's the curve. There's a 70% chance that Methuselah's star, the antiquated heavenly wanderer, could be around. There's a 13.66% opportunity that this antiquated star's age is playing outside the inestimable rulebook. Moreover, there's a 15% chance it's not as old. In any case, just more youthful. Imagine rolling a standard 6-sided die and expecting a specific outcome. Regardless of what these inestimable twists throw at us, one thing is certain: Methuselah's star isn't simply a giant veteran. It's the granddaddy of stars. We sorted out how to give it an age, a name that is darn exact. Now here's where it gets great. Rather than scratching our heads about where Methuselah's star could be 2 or 3 billion years more seasoned than its huge neighbors, how about we flip the cosmic content? Consider the possibility that the actual universe isn't as youthful as we once naturally suspected. We've been attempting to make heads or tails of the limitlessness of space, and assuming we turn the whole history of the universe into a vast schedule with the Big Bang as the most amazing New Year's firecrackers, Earth wouldn't join the infinite sledge as late as possible into December 31st human recorded history. That is only a blip in time covering just the last 10 seconds. Our cosmic analysts decide the universe's age by looking at old starlight 2 or 300 million years after the Big Bang. As the universe extends, it gives this light a huge makeover known as redshift. By figuring it out on both distance and extension, experts pronounced a general season of 13.8 billion years. Yet hang on, since the Big Bang, this circumstance is going to get intriguing. A review from the University of Ottawa suggests the universe may be an incredible 26.7 billion years old. Professor Rinder Gupta gets on a charming hypothesis from 1929 made by Swiss space expert Fritz Zwicky, and it's stirring up our grandiose understanding. This hypothesis suggests that as light particles, photons, travel through the boundlessness of space over time, they lose a portion of their energy. This thought doesn't flawlessly line up with what we've seen through our telescopes. Gupta proposes an infinite compromise. He suggests we can mix this hypothesis with our ongoing comprehension of a developing universe, making a mixture clarification for the redshift peculiarity. Now, lock in, changing the universe's age to an incredible 26.7 billion years is no small feat. Gupta adds one more wind to the huge blend by joining the light loss hypothesis with developing coupling constants, a brainchild of hypothetical physicist Paul Dürr. This thought suggests that the way particles connect may have changed over time. And hey, researchers have a past filled with tweaking the vast clock back. In the 1920s, Edwin Hubble thought the universe was just a simple 2 billion years old. We've progressed significantly from that point forward, refining our cosmic math and expanding the universe's age like bringing a giant leap into our huge seeing. However, whether this new viewpoint turns into the cosmic norm is still up in the stars. Whether human history is a straightforward blip of 10 or 5 seconds in the grand plan of the universe, one thing is certain: the universe is a motherlode of old marvels and perpetual motivation. Looking to our huge lawn, the Milky Way, there's a staggering, tremendous tango occurring in the universe. Ongoing appraisals hint that stars on the edges of our universe are swaggering their stuff in sluggish motion contrasted with their accomplices in other cosmic systems. What's the galactic scoop? Well, there are a couple of speculations, and one hypothesis is that our Milky Way may be running really short on an imperceptible huge fixing called dark matter. This subtle substance impacts the gravitational dance of excellent articles. There's a heavenly secret involving dark matter, the strange substance we can't see, yet it appears to play a gravitational to and fro in the universe. One chance that is shaking our tremendous comprehension is that maybe we've been assessing dark matter wrong. Our general compass may point off kilter. Here's where the European Space Agency's Gaia satellite steps into the inestimable spotlight. It's like our cosmic inspector, giving complex experiences into the dance of almost 2 billion stars in our Milky Way. Consider it an enormous improvement test. The satellite's exact estimations have driven space experts to reconsider their huge notes. Stars at the external edges of our Milky Way appear to be moving slower, testing our old suspicions about their paces. How do star speeds spill the grandiose beans about a cosmic system's mess? It's like really taking a look at the size of a party by how rapidly individuals are moving. Equipped with Gaia's information, space experts assess the absolute mass of our system's gas, dust, stars, and that subtle dark matter to be around 200 times the mass of our sun. It seems like an inestimable heavyweight, yet here's the wind. It's multiple times less than we recently suspected. One hypothesis to settle this galactic riddle proposes we might have been altogether too cumbersome with our dark matter gauges. Perhaps there's less dark matter out there than we once thought. Anyway, hang on. Estimating a system resembles attempting the unthinkable. The information could have a couple of peculiarities, or our astronomical estimating tape could require some changes. On the other hand, other exploration groups have joined the enormous assessment, and they all appear to be murmuring the same universal tune. If this unprecedented disclosure holds, it's like opening a new part in our vast material science course. A turn that could make us reevaluate not just our own Milky Way but every sparkly corner of the universe. As Stacy McCarr, a space master at Case Western Reserve College, puts it, this could be a huge game changer. Returning to the 1970s when stargazer Vera Rubin and her huge group set out on a divine mission, their objective was to concentrate on how stars moved in various worlds. The inestimable playbook proposed that stars on the edges of a cosmic system ought to be slow movers, contrasted with the zippy stars nearer to the middle, like how Neptune takes as much time as is needed circling the sun while Mercury is the timeless speedster. However, what Rubin and her group found was a vast shock. Stars at the far reaches of systems were moving at almost the same speed as those nearer to the cosmic dance floor. Imagine a giant disco where everybody, regardless of where they are, is moving to the same beat. This gigantic disclosure suggested the presence of something confusing and imperceptible. Dark matter, the inconspicuous heavyweight champion that forms huge radiances around systems. Contemplate early space specialists like Copernicus and Kepler. We've advanced so much from that point forward, but we're still the newbies wide-peered toward at the cosmic wonders, attempting to disentangle the universe's insider secrets. Our Earth is like a minuscule island in the immense expansive room, twirling around the sun, encompassed by endless stars. Our mission for significance among the stars is at the core of logical examination. In any event, when answers shock us, this interest keeps us voyaging further into the universe. It's a ceaseless venture where every reaction brings new questions, guaranteeing our astonishing assessment never stops. The universe keeps on shocking us with its immeasurability and intricacy. Every revelation takes us deeper into the complex embroidered artwork of enormous history, disclosing the basic standards that oversee our reality. Continuous exploration has shown that cosmic systems aren't confined elements but are interconnected through a mind-boggling web of dark matter and gravitational powers. This understanding leads us to rethink our models of cosmic system arrangement and advancement. Quite possibly of the most captivating part of galactic research is the idea of gravitational waves, swells in spacetime brought about by probably the most outrageous occasions known to humankind, like merging black holes or neutron stars. Previously recognized in 2015, these waves offer a better approach for noticing the universe, giving bits of knowledge that customary telescopes could miss. They open a window into peculiarities that are imperceptible to electromagnetic radiation, permitting stargazers to concentrate on occasions from the early universe and work on our comprehension of the principal powers at play. Moreover, analysts are additionally exploring exoplanets, planets circling stars outside our planetary group. The revelation of possibly tenable universes brings up huge issues about the chance of life beyond Earth. Methods like travel photometry and radial velocity estimations help recognize these far-off planets, uncovering other planetary frameworks that test our presumptions of how planetary groups ought to frame. A portion of these exoplanets lie in their star's habitable zone, where conditions might be ideal for liquid water, a critical element for life as we know it. As we test further into the universe, the job of artificial intelligence in dissecting immense sums of information turns out to be progressively critical. Simulated intelligence calculations can identify designs and irregularities in divine light bends, prompting the revelation of new heavenly bodies and peculiarities at a speed already incredible. This coordinated effort between human instinct and artificial intelligence moves us into a period of uncommon galactic disclosure.